All right, welcome back again. Let us look into the next set of questions where we have to find the value of a and b, and we've been given 5 plus 3 root 2 upon 5 minus 3 root 2, which is equal to a plus b root 2. Now if we were to look into the left hand side where we have 5 plus 3 root 2 upon 5 minus 3 root 2, what we are going to do is we are going to rationalize the denominator. Rationalizing the denominator means eliminating the root part from the denominator. So I'm going to multiply it with 5 plus 3 root 2. 5 plus 3 root 2. We'll take the conjugate terms, which is equal to a plus b root 2. Fine. Now here we are having the numerator same. Now this can be written as 5 plus 3 root 2 whole square. Now this follows a minus b and a plus b's formula, which is equal to a square minus b square. So this becomes 25 minus 18, which is equal to a plus b root 2. Now this becomes a plus b whole square formula. Now this can be written as 25 plus 18 plus 5 3 is a 15, 15 2 is 30, 30 root 2 upon 25 minus 18 is 7, which is equal to a plus b root 2. Great. Here again we get, if we were to solve it further, if we add this thing together, we get 43 plus 30 root 2 upon 7, which is equal to a plus b root 2. We will further write it. This can be written as 43 upon 7 plus 30 root 2 upon 7, which is equal to a plus b root 2. Now we're going to compare the conjugate. We're going to compare the parts where we get the value of a as 43 upon 7 and b part, which is going to be b root 2, which is equal to 30 root 2 upon 7. Root 2 gets cancelled, so the value of a comes out to be 43 upon 7 and the value of b comes out to be 30 upon 7. Now this is our answer. Here let's see the next log question where we have to prove 2 log 15 upon 18 minus log 25 upon 162 plus log 4 upon 9, which has to be proved to log 2. Okay, what I have done is I have noted down the question once again. Now this coefficient becomes the power of 15 upon 18. Now this can be written as log 15 upon 18 square minus log 25 upon 162 plus log 4 upon 9. Now which is to be proved to log 2. Cool. Now if I were to take log common, what would I get? Log common. Now 15 square is 225 upon 18 square is 324. Now this division, this minus sign changes to sign of division upon 25 upon 162. Now this plus sign changes to multiplication 4 upon 9. Now which has to be proved to log 2. Fine. Now we'll solve it further. 225 upon 324. Now we'll change the sign. This divide will change to multiplication 162 upon 25 into 4 upon 9, which has to be proved to log 2. Great. Now what we can do is we can cancel the terms. Now 162 ones are, now this is 1 times and this is 2 times, 25 ones are and 25 nines are, and 9 and 9 gets cancelled, and 2 ones are, 2 twos are. So what do I get? I get log 2 here, which is equal to log 2. So my LHS is equal to RHS. So hence proved. Yeah, let's see the next question. In triangle ABC, BE and CF are the medians. M is a point on BE produced such that BE is equal to EM, and N is a point on CF produced such that CF is equal to FN. Now what we have to prove here is NAM to be a straight line and A to be the midpoint of MN. Okay, firstly let us draw the diagram of the given question. Now this is the triangle A, B and C. Then we have BE and CF. BE and CF, the required medians. Now M is a point on BE produced. M is a point on BE produced such that BE is equal to EM, and then N is a point on CF produced. N is a point on CF produced such that CF is equal to Fn. Now what we can do is we can join N with A and A with M. Now as a constructional part we can even join F and E. Fine. Now let us see what can be derived from the figure, the given diagram. BE, which is equal to EM, because E is the midpoint of BM, and CF, which is equal to Fn, because F is the midpoint of NC. Great. Now let us consider the triangle A, B and M. ABM, where F and E are the midpoints of F is the midpoint of AB, and E being the midpoint of BM respectively. Therefore FE becomes parallel to AM, and FE becomes equal to half of AM, and that is by midpoint theorem. Fine. Similarly, now let us consider the triangle ACN, where F and E are the midpoints of F being the midpoint of CN and E being the midpoint of AC respectively. Now what can we conclude from this? We can conclude that FE is parallel to AN and FE is half of AN, and that is again by midpoint theorem. Okay, fine. Let's see the first case where FE is parallel to AM, and in the second case we have FE being parallel to AN. Now what can we conclude from this? It means that AM and AN lie on the same straight line. You can see it through the diagram also. They are lying on a same straight line with common point. Now what is the common point? Now the common point is A. The common point is A, and they are all parallel to EF. Parallel to EF. Now this concludes that NAM is a straight line. So this is the first part of the question. Okay, cool. Let us see the second part of the question where we have to prove A to be the midpoint of MN. Now from the first case where FE was parallel to AM, we got FE which was equal to half of AM, and in the second case where FE was parallel to AN, we got FE which is equal to half of AN. Now what can we derive from there? Where FE and FE are common, half of AM is equal to half of AN. Now what happens is half and half get cancelled. I get AM which is equal to AN. Now from this we can conclude that A is the midpoint of MN. So this concludes our question. Fine. Thank you for hearing me patiently. This brings us to the end of the video. Please like, comment and subscribe the channel. Meet you soon in the next video. Bye bye.